So learning targets. I can find domain and range of rational functions. Not too difficult. I can algebraically transform the reciprocal function. That's the one that's going to take most of our attention today. All right? So, let's get started with just some quick review. What is a rational function? They're functions involving what? Fractions. Fractions. All right? Involving fractions. Remember, we put the letter F in front of rational. It sounds like fractions. Fractions. So, rational functions, they're fractions. And what about domain and range? What do they mean? Domain is what? And range is? You got it. Don't forget, we can also refer to the range as all possible outputs. But also, because in PreCalculus, especially calc, they really, sometimes they say y equals, sometimes they say f of x equals. So it could be all values for f of x. Same deal applies. Right? Here we go. Let's find the domain and range of the following function. Well, the domain should be easy here. What's our domain? They're all possible x values. So as I look at that function, it's a rational function because there's a fraction involved. What can my x's be or not be? Correct. So what does that mean? So x cannot equal 2. There we go. That's the domain. It can be any other number. It can't be 2 because it's stated we can't have a 0 in the denominator. That would make it undefined. So that's our one big no-no. That's right for domain. It can be anything but 2. What about our range? What about our range? Now, we can use any number besides 2 for x. And if I put in anything besides 2 for x, what can I possibly get out? What can be my output? My f of x or my y? It's close. You can get a positive, you're very close. You can get a positive value, right? Because what if I made x 4? That would be a positive value. What happens if I made x 1? It'll be negative, so you get positive negatives. What if I made x a 0? Would that give me 0? No. What number would I have to put in for x to get a 0 out of that fraction? 2 we can't use. It's not in the domain. It'll be undefined. You can't get 0. How come you can't get a 0 in this fraction? How do I get a fraction to be 0? Well, 0 at the bottom makes it undefined. You need a 0 on top, right? 0 over any number, whatever it is, will always give you a 0. Right? Can I change the numerator here? No, it's always 1. I can never make it 0. So I can get positive numbers, negative numbers. I just can't get that to equal 0. So my range, I will say f of x cannot be 0. Right? I think so. Now, asymptotes. Asymptotes, asymptotes. Let me see here. Let's see what's down here. Now, vertical asymptotes are the easier ones. Because vertical ones, they're x equals. That means if I have an axis right here, and I have an asymptote at, let's say, -6 on the x-axis, that's the vertical line that touches -6 on the x-axis, okay? So verticals are associated with the x. If I look at my domain, what's the one thing that x can't be? 2. So guess what? I have a vertical asymptote. And I have vertical asymptote at x equals 2. So once I find the domain, that becomes my vertical asymptote. I'm really halfway done with finding my asymptotes. Horizontal is slightly different. Not that much harder, but slightly different. Okay? I take my function, and I keep the biggest term. You guys remember this?
Oh, you take the biggest up on top of the bottom?
Yes, I keep the biggest terms on the top and the biggest terms on the bottom. Okay? In this case, my only term on top is 1. What's the biggest term on the bottom? The x or the negative 2? The x. And I need to see what happens as x approaches infinity. It's actually called taking the limits as x approaches infinity. First, I see if I can reduce that. Can I reduce this fraction at all, 1 over x? No. So now, let's put my infinity in for x. As the bottom of a fraction gets bigger and bigger and bigger, what happens to the overall value of that fraction? It decreases. 1 over 1 would be 1. Now let's shrink the bottom. 1 over 2. That's a half. That's smaller. 1 over 4. It's a quarter. That's smaller. 1 over 10. It's a tenth. So it's smaller and smaller and smaller. So it approaches. It would eventually approach 0. It'll never be 0 because we're going to 0 on the top, dude. But it will get so insignificantly small that it'll seem like 0. Therefore, we have a horizontal asymptote at y equals 0. Yeah, I'll graph this first one here. I'll graph this first one. Let's graph this and see how we did. Okay? Remember, y equals, clear this out, and I'm going to graph, what is that, 1 over x minus 2. I'm going to create a fraction, saying 1 over x minus 2. And if I graph that, there we go. We'll move this out here. There it is. Here's our graph. We indeed have a vertical asymptote. That's at 2. At x equals 2. Okay? And our horizontal asymptote, well, here's 1, here's 0, here's negative 1 on the y-axis. Is right here. And we definitely have that. So we nailed it. Job well done. You guys, see how you can do with this one. Okay. So, what do we find out? What's our domain here? X cannot equal? Okay, positive or negative 1. Let us not forget that when we square negative 1, that still turns positive. And that would make the bottom equal to 0. Okay? And now this, well, why don't we just do a vertical asymptote now? Because they kind of tie in hand to hand. What are our vertical asymptotes? Yeah, so x equals positive and negative 1. You're going to have 2. So that's what this is for. That's why it's nice to do these just right next to each other. All right? The range. The range. Yeah, f of x cannot equal 0. It's the same situation right here. Now, I can get positive numbers, I can get negative numbers. Absolutely. How can I get a negative number? What value of x will give me a negative number? 0. If I throw a 0, yeah, I can throw a 0 in for my domain. I just can't throw in a negative 1 or positive 1. If I throw in a 0 here, 0 minus 1 will give me a negative 1. A negative 1 over negative 1 is positive. And I can use decimals. I can use 0.2. But I can get large positive numbers. But just not have a negative at the bottom. You can if the number is smaller than 1 if you square. 0 squared is less than 1. What about if I took 0.5 and squared? It's 0.25. That's smaller than 1, so if I subtract 1, it's going to be negative, you know? You can always look at your table on your calculator to check. All right? You might have to change some values, but I'll show you that in a second. All right, now let's do the horizontal asymptotes. Bam! What am I doing?
Oh, you see the highest number on the top and the bottom, so you get negative 1 over x squared.
Highest term on the top and bottom. Negative 1 over x squared. Can I reduce that? I don't think so. And let's throw in infinity in for x. So that is negative 1 over infinity squared, which is infinity. Okay? And it does get smaller, and it will approach 0. Okay? So at y equals 0. So let's graph this and see if we're right. Negative 1 over x squared minus 1? Come on, y equals, clear. Negative 1 over x squared minus 1. Right, if I graph that, asymptotes would be, look at that, both at negative and positive 1 are the horizontal ones. Okay? Yes, I mean vertical. There's negative 1, there's positive 1, we have 2, and there's 0. Good. Sweet. Looks like we know what we're doing. Not too shabby. Now, as far as the table goes to check your range, I mean, look at that. I changed this already. Let me change it back. Normally, we start like this, okay? If I look at my table, it doesn't look, I see fractions. I see negative fractions. It doesn't look like very large numbers, does it? In fact, it looks small. But if I get small values of x, and note that I can't do negative 1 or 1, see they're both errors. But let's change our table set that we'll start at 0 and go to 0.1. Because that table's only showing me whole numbers. Let's see decimals now. Let's see what happens. Because now look at these. See they're going up and up and up. Look at that. In between, right before the number 1, it's starting to get big. Got to 5. Now if I change that by even more, if I were to show like 0.999 or 0.999 and keep on going, that would get extremely, extremely large. Okay? So it does go up and down forever, which is cool. Right? Transforming the reciprocal function. Okay? The reciprocal function is 1 over x. That is the reciprocal function. This is it right here in all its glory. Why do they call it the reciprocal function? Well, x is our variable, and if we get the reciprocal of that, we just flip it. That's the reciprocal function. Okay? That's the title. We went over our like 12 major functions, and reciprocal was one of them. So if we want to make a function into a reciprocal function, all this is breaking down the function so that you end up with a 1 on top. All right? So let's get into it. All right? Now, example 3 says, if f of x is 1 over x, that's a reciprocal function. Let's write the reciprocal function of g of x. All right? Then describe the transformation of f of x. That sounds kind of weird, but let me demonstrate to you how we do it, okay? No, that would make it too easy. No, we just don't flip this. We're going to represent this in a manner to where there's a 1 on the top. If I were to just flip this, that's another 1 on top. Okay? We want to make this into the reciprocal function, which is this. We don't want to just take the reciprocal of g of x. We want to turn g of x into the reciprocal function, which is 1 on top. But watch, it's not that difficult for this one. G of x equals 2 over x plus 3. Okay? Isn't that really the same thing? I can say that's 2 times 1 over x plus 3. Because I was multiplying them together, isn't that 2 over 1, and I multiply the tops and bottoms? So guess what? That is now a reciprocal function. It's 1 over x plus 3. But for this part here, we are going to put this back into f of x. We're going to put that back into here. All right? And that's going to help us describe the transformation. Meaning, well, in this function, if I had a 5 here, wouldn't that be 1 over 5? Right? Whatever goes into the x goes there. Well, what's on the bottom of our fraction here? X plus 3. So that's like saying f of x plus 3. That would give us 1 over x plus 3, right? It would. However, I'm still missing what?
2.
The 2. So if I want to multiply this function by 2, I'll just put that right here. And that would give me, I'll rewrite this, that would give me my 2 times 1 over x plus 3. Okay? That's it. So this is the same function, but but we put it into the reciprocal function, okay? Now, we're going to describe how that moves based on, oh man, Unit 1 stuff. Unit 1 stuff. Do you remember what happens if I add or subtract inside the parentheses? How does it move? Well, you're right. If I'm adding, what does the graph do? If I add or subtract on the inside, the graph is either going to move left or right.
That's right.
Okay? If I add or subtract on the outside, it's either going to move up or down. And if I multiply on the outside, that's just going to stretch it vertically or compress it vertically, okay? If I negate the outside, that flips it vertically. So, if I'm adding 3 to the inside, what does this tell me is happening? It's moving left. This means it's moving left 3 spaces right here. And the 2 tells me that it's a vertical stretch by a factor of 2. And I hate the word. Vertical stretch. Because that's kind of like slope. If there was no number here, we assume it's 1. A slope of 2 is steeper than a slope of 1, isn't it? So that means it's going to rise faster. It's going to stretch it vertically. Now, if this was 1/2, that's not as steep as 1. That would be pressing it down. Okay? So, we can actually check this. The graph. You know what? Oh, you can do it right in the calculator. Let's graph. Clear. Let's graph our reciprocal function right here. That's what it looks like. Okay? That's what it looks like. Our reciprocal function. In fact, it's probably zoom in, but that's fine. It looks like this. It goes here, and it goes here. That's 1 over x. The function we were given, g of x, should move to the left 3, okay, and stretch 2. So if it moves to the left 3, I go, this will move 3 to the left, bam, like that, and it stretches, which means it's going to kind of pull. It's going to kind of pull. It'll look the same because the curves, but it's going to pull. It might advance a little bit steeper. So let's see if our new graph looks like that we had in blue. And that, what is that graph? The original one. 2 over x plus 3. Equals, clear, 2 over x plus 3. Oh, that's nice. That is almost exactly to a T what we just drew right here. There it is. Look at it. That's almost perfect. Man, we're good. I love being right, don't you? Devil 4 is the same thing. We want to write the reciprocal function of g of x. Okay? And then describe the transformation. So, notice the difference between example 4 and example 3. Example 3, there's just a number on top here. Okay? For example 4, it is not that. Okay, there's a 3x minus 7. I can't just pull that in front and put 1 over x minus 2, because then I don't know what's going to be in front, because I don't know what x is. Alright? So, back to our friend division. Okay? Now, I'm going to divide these two. Okay? I'm going to say x minus 2 goes into 3x minus 7. Now, I can do that. Can I do synthetic division here or not? No. Why not? I can. Yeah, because this is linear with a 1 right here. As long as I can do that, yeah, I can use my negative 2. So that's what it do. That's a lot easier. I'm going to put negative 2 into here, and it's going to go into my 3 and my negative 7. Now, here's the $1 million question. I drop a 3. And what is negative 2 times 3? Do I add or subtract this negative 6?
I add it.
How come I subtract it? Yeah, this isn't x equals. This is a factor. If it was x equals, it would have been x equals 2. That's the factor, so I subtract it. When I subtract the negative, it's like adding negative 7 plus 6.
Negative.
Now, here's how we write this. This is the remainder. Okay? If I'm going to evaluate this right here, my answer is 3 with a remainder of -1. Well, -1, that was radical -1. This isn't radical. It's my remainder. Now, let's bring back to this. If I divide 5 into 9, it goes in there once, right? What's the remainder? The remainder is 4. And that's the same thing as saying 1, and I have 4 out of 5 left, right? 4/5.
Yeah.
The same thing's here. This remainder can go over whatever I'm dividing into it, my x minus 2. So that's a negative, so I can say plus a -1 over x minus 2. I'm going to use that to put into my f of x. Okay? I'm going to use that to put into my f of x. What do I mean? Well, this is a positive 3, right? So I'm going to even write that. That's a positive 3. And whenever I add a negative number, that's like saying -1 over x minus 2, right? Because I added a negative here. So that's just like saying minus 1. Yeah. Okay. All right. Now, if I'm going to put this into f of x, what is at the bottom of my fraction there? X minus 2 is going right here, isn't it? It's x minus 2. So I'm going to put that as x minus 2. Well, what am I doing with the 3? No, that was what was on top of the fraction comes out front, doesn't it? Well, what am I doing? It's a positive 3, right? Is it adding 3? No, it's adding 3. Now, some people it might be easier for you to recognize the next step this way. Wasn't this plus a -1? Isn't that the number that came out in front of the f? It was a 2 last time, it's a -1. I don't have to write a 1, but I definitely have to write the negative. That's the function. Take a look at what we did. This right here. So take a look at how it's structured. Okay. That's our fraction. It's my homework. Now, oh, that's an issue. Now, what is happening to f? What are the movements for f?
Stretch negatively by 1.
Well, it's being stretched by -1 by factor 1, which means it's not really stretching. But if it's a negative sign, this means it's flipping it vertically. Remember, if you had something like this, I would flip it, and it would now look like that. I would flip it vertically. Okay? So it's a vertical flip because of the negative sign. What does a -2 and a positive 3 do?
Oh, and -2 moves it right.
It's moving right 2 spaces. No, this will move up 3 spaces. It's weird.
Because it's like everything else is inverse.
Yes. When outside is regular up and down. Positives go up, negatives go down. But inside it's flipped. Okay, inside it's the opposite. Negative moves to the right, positive moves to the left. So if I know this is the graph in red of 1 over x, okay? Well, not only will it flip vertically, which means this top right thing will go here,
Right.
and this bottom left will go here, but after I do that, it's going to move 2 to the right and up 3. So if this is 0, it's going to go 1, 2 to the right, 1, 2, 3 up. So this will move 2 to the right, and 3 up. This will move 2 to the right, and 3 up. It'll look like that green graph right there. We hope. Let's all hope. And that is 3x minus 7 over x minus 2. That's graphics. Alpha y equals, enter 3x minus 7, and it's x minus 2? Now let's change the window. Let's go from, that's going to be 3. Let's go to minus 6 to 6 so we can see a little bit better. Look at us go. Look at us go. That's exactly what happens right there in the green. Like this, and like this, we're to continue off like that. Just like the green on that graph. Perfect, perfect, perfect. Go.
So you put -2.
Okay, so we're gonna say, wait. We're dividing this, right?
Right.
So
You do synthetic.
if I use synthetic, how am I gonna set it up?
Oh, you got x plus 3.
So what goes in? The
Oh, the
3,
goes inside.
2, and then -1. And drop the 2. And what goes in here?
5, 6.
And do I add or subtract?
Okay.
So that is my remainder. Okay. Now, how do I write that? 2 plus perfect. And this is a positive 2, right? Positive. So let's write that. What goes into my x here? What's in the bottom? Yeah, right here. X plus 3. What do I do with the 2? Plus 2 at the end. What do I do with my numerator here? -7. You know what? I don't know if this matters or not, but since it says we gotta get a 1 on top, technically, I should write this as a positive 2 plus, I bring the -7 down in front so that I can keep a 1 on top. You know what I'm saying? -7 times 1 over x plus 3. This is a true reciprocal because there's supposed to be a 1 on top. You see what I'm saying? I mean, it means the same thing. But if you see it written this way, now you know. So my -7 comes out front. And how is this going to move?
Oh, so it's moving left 3 spaces.
Perfect. It'll move left 3 spaces.
Up
It will move up 2 from the original reciprocal function.
to one stretch.
It'll be a vertical stretch
It flips to the negative.
by a factor of 7. And this right here, well, it'll be a vertical flip. It's nice. So, and I'll just do a little sketch right here. This is 1 over x, our reciprocal. It is going to flip, so it'll flip down like this, and this one will flip up like this. The red will flip to green. It will stretch by 7. I can't really show the stretch, you'll see on the graph. It'll move left 3 and up 2. It'll move left 3, up 2. So, right there. Something like that? Where that green is where it's going? Let's do this. 2x minus 1, x plus 3. Ready? 2x, is it minus 1?
Yeah.
Minus 1, x plus 3?
Yeah.
Let's make that window so we can see it. Let's go to Zoom Standard 6. There we go, that's right where the green is. Right where the money is. Right where the green is. Right there. It's almost exactly to where that green is, we wrote it. Perfect, good, well done.